Good morning, fourth graders. I'm usually teaching with a lot of natural light coming in from the window that's right in front of me. You can't see it, but it's there. And yeah, it's dark. So it's either super early in the morning or really late at night. I'm not going to tell you which one, but it's dark outside. Today, I am super excited that I will be teaching your lesson on Friday. Next week, you'll be getting your math lessons from Mrs. Mitchell. And so kind of exciting. We get to kind of flip-flop and see how that's going to go. It's going to be cool. Now, what I wanted to just let you know that you guys have been doing amazing work. And I'm so seriously so proud of all of you fourth graders. I watch your assignments coming in throughout the day. All the teachers, Mrs. Mitchell and I, we can see those coming in throughout the day. And I just keep thinking, wow, they are working so hard. So thank you so much. And just keep up the good work. We love you all so much. Now, today is going to be a little bit of a different day. I'm going to explain why in just a second. But let me share with you my screen and I'm going to explain what our lesson is today. Our lesson today is lesson 6 in module 4. And the objective is to use varied can't even speak. Use varied protractors to distinguish angle measure from length measurement. Okay. I want you to think about this word varied. That word varied means it changes. So being able to deal with protractors that look different, okay? They change, they look different. So being able to work with a wide variety of types of protractors is going to really benefit you in your future, because not every protractor you ever buy is going to look the same. Let's see here. Another word you're going to want to know is distinguish. So basically what this means is telling you the difference. And when you're using different types of protractors to tell the difference between angle measure and length measure, that just means you're going to be able to tell the difference between those. All right, friends, the reason why today is going to be a little bit different is because we're not actually going to do the problem set. I'm not requiring you to do the problem set. You are going to be required to do other things, but not the problem set, and this is why. The problem set requires that you have a protractor to measure angles. Now, I can't guarantee that all of you are going to have access to protractors. One thing I wanted to start out with is types of angles, vocabulary words. So on vocabulary, there's so many amazing resources that your teacher can use to help you learn. Now, these are all vocabulary words. So let's just quickly review those so far, what we've learned so far this week. So acute. Acute means of an angle less than 90 degrees. Remember, it's small, it's cute. An acute angle is less than 90 degrees. So, and used in a sentence, an angle that measures 65 degrees is an acute angle. Antonym is something that means the opposite. All right, so obtuse would be the opposite of acute. Next word is angle. The definition: a figure made by two intersecting lines or rays extending from the same point. Okay. Degree, a unit for measuring angles. A 1 degree angle would be very, very small. We know that when we looked at our big circle here, and it was 360 degrees total, and when you're splitting it up, first we split it into fourths, and each of those fourths were 90 degrees, and then we split up each 90 degrees into 45 degrees, and then each of those into something smaller and smaller and smaller, and it showed you that tiny degrees. So it's really hard to get that perfect angle measurement. That's why we always say if it's off a little bit when you're actually measuring with a protractor by like a degree or so, it's okay, because a 1 degree angle is tiny. Obtuse. Obtuse means of an angle between 90 and 180 degrees. Now, it has to be more than 90 degrees, because a 90 degree angle we know is a right angle. So if it's 91 degree angle, it's obtuse because it's more than 90 degrees. And it can go all the way over. So let's say this is our right angle. It keeps going all the way over. It's obtuse. And then once it's hit here, wow, that's hard. Once it hits here, it becomes what we call a straight angle, which we'll see later. Array, a line that has one endpoint. Right angle, a 90 degree angle, it is formed by two perpendicular lines or line segments. And we showed that These are 2 line segments as they don't have the arrows at the end. And then we show that it's 90 degrees with that square where the angle lies. If that is a square right there, you know it's a right angle. You know that's the only way we mark 90 degrees, okay? A straight angle, this is what I mentioned. When it keeps going from 90, then it goes obtuse, and then eventually to a straight angle, gets flat. It means it's a 100-degree angle, and it looks like a line. So a lot of you have probably seen that on IXL already. So it goes halfway through the circle, okay? 180. So I want you to think about this. Now, I grew up snowboarding. Some of you snowboard. Some of you ski. I love that. Now, let's imagine you're going down the hill, you're snowboarding, and your friends are saying, yeah, do a 180. What that means is you are twisting your body. Okay, so you're facing forward, you're twisting your body halfway, okay? 180 degrees. Now, if someone says, do a 360, I can't do it because my arm would be twisting out of place, but you would be twisting all the way around again and facing forward. So 360 means going all the way over, all the way to where you're facing forward again, but 180 means only halfway. That's why it's straight and flat. And our last vocabulary word is vertex, the point where 2 lines meet to form an angle. So often we say the corner or the vertex. So the vertex is when we're dealing with angles. I did want to share with you a portion of a video. In this video, you're going to see a different type of protractor being used. Sometimes we use protractors that are not so user-friendly, which means they're not that easy to use. We have to use some problem solving. So I'm going to have you watch carefully in this video. That way you know what to do if that ever happens to you.
In this case, you can see that we clearly have an acute angle. So we know the angle has to be less than 90 degrees. But we're going to change. Instead of using this protractor, which we've used before, we're going to change the protractor style to this one. And it's a different kind of protractor. It'll give us the exact same answer as the other protractor. It just looks a little different. And in this case, the target is inset a little bit. It's not directly on the edge of the protractor, which means the 0 is also not directly on the edge of the protractor. It's inset a little. So you just have to be aware of that. We know that step 1 is to place that target directly on the corner of the angle, the vertex. So the target is now on the vertex of that angle, and we're going to rotate so that one of the legs is lined up with 0. So as I do that, I'm going to get really close as I can. Boom, close enough. And there. So one of the things you'll notice, and I did this on purpose, is this protractor does not have 0 at both ends. It only has 0 at one end, which means when we've lined up this angle on to what we thought was a 0, this angle now is pointing somewhere between 130 and 140 degrees. But we know that can't be true because this has to be an acute angle. And so what we're going to do, we don't have to reset anything. We don't have to rotate the protractor. What we're going to do instead is we're going to pretend that this right here is 0. And so when we move over, we've moved over 10 degrees. And each time we move over, that's going to count as 10 degrees. So we could just count kind of like manually. So 10, 20, 30, 40 degrees. And we can't go to 50. That's 50 degrees over here. We can't go there. So there's 40 degrees. Now I'm going to zoom in a little bit, and it looks like it's like another 2 degrees. So let's call it 42 degrees, and let's see how close we are. And look at that. Woohoo! We're right. All right, now the point is, remember, these degrees are so tiny. Each degree represents 1/360th of rotation. So imagine taking a cake and cutting it into 360 pieces. Each piece is going to be really thin. And that's exactly what a degree is. So if you're off by a degree or 2, that's all right, as long as you're close, within a degree or 2. You don't have to be totally perfect. And that is how you measure angles with a protractor.
I want you to think about what he just shared in that video. Now, plenty of times in my life, I have been frustrated by using a protractor that only measures from 0 to 180 and then doesn't go from 0 to 180 on the other side. Because usually you understand that angles, or if you're measuring a shape or a triangle, it can go this way or this way, right? So you want to be able to see it both ways. I was always frustrated at companies that didn't make the protractors easily readable, right? But it happens. So I want you to use that knowledge he taught you. Now, if you have to start and pretend something is 0 degrees and then just count it by tens and count it in your head, you have to do it that way sometimes. Now, using the knowledge that we've covered, I mentioned that we're not doing the problem set. Instead, I really want you to focus on your IXL lessons you have not yet completed. So we're going to be including a list of all the lessons you would have wanted to complete this week. And I want you to really focus on doing IXL today for your math assignment. Let's review some of the problems. I'm going to take a look here of what I've started on the right. So it says Z angles. So far you should have done already 1, 2, 3, and 4. Okay, so those were assigned previously. Now if you haven't, then you're going to want to get started where you left off. What we're going to look at today is we are going to look at this one that says new. Okay, this one's kind of an optional one, but I actually think it's kind of fun. And what I'm going to do is it says, well, I'm going to use the protractor. And I'm going to zoom in so you can see a little bit better. But it says use the protractor to make a 55-degree angle. Now, it's starting at 0. Okay, remember it goes from 0 to 180. Or you can start over here if it wants us to. But it wants us to start here at this 0. So here's our vertex here. There's no other line. We're just going to be making that line. So it's flat, and then we're going to take this and move it up to the 50. Okay, we're here. And then we're going to go all the way up to the midway point, 55. Okay, so I did that. I'm going to click submit. Fantastic. We are rockstars. Now it goes to the other side. Use the protractor to make a 155-degree angle. So if you notice that we did 55 degrees, that's acute. It's less than 90, so it was acute. Now, I already know that's going to be an obtuse angle because it's more than 90 degrees. So we passed our 90 degrees. That's our right angle. It says 155. I'm going to go all the way. Remember, look at the bottom numbers right here. So go to all the way. Let's move over so you can see. Move all the way over to 150 and then 155. So do you see how there's not the little lines down here? You have to use, well, there's a midpoint, so that's easy peasy, but all the little lines are up here. So you have to look really carefully. So I can move it bit by bit. And it also automatically just kind of hops over for you, which is nice. So it looks like it's 150, 155. It's not at 160 yet. Let's click submit. Correct. So that was an obtuse angle. Of course, it's going to ask you things like use the protractor to make a perfect 90-degree angle, and you'll do that as well. Okay, so I want you to give that one a go. Exciting stuff. And don't forget, whoa, it unstarred. I know, silly. Keep it on there. All right, so the next one I want you to do is number 5. This is after you've already completed the top ones, right? So number 5, estimate angle measurements. This is where, I'm not gonna lie, it gets a little bit tricky. What is the measure of this angle? Choose the best estimate. Okay, you really have to think about angles here. Just keep in mind that if it's 90 degrees, that L shape, it is a right angle. And if it's smaller than that, you kind of have to imagine your head's going to be smaller 90 degrees, or if it looks like this, it's going to be greater than 90 degrees. Well, I'm looking at this. Now, I'm going to use my pencil to show you. If it were up and down like that, it would be 90, right? But it's not. It's acute. It's going to be less than 90. It's right here. So we just say, no, no, no. Let's get my eraser. We're like, yeah, we already know that, Mrs. Rourke. So I'm looking here. It's less than 90, so it's not that one. 135, no, that would be more, 30 degrees or 60. Now, if it were 30, remember 30 is a third of 90. That 90 is up there, a third would be more like right here. So that would be 30 degrees, but it's 60, okay, which is 2/3 of 90. So we're thinking, yeah, that sounds pretty good. 60 degrees, let's see if we're right. Super duper, love it. So that's what you're going to be doing on these. The last one, my friends. Let's go back here. Sometimes computers are slow. Don't we just love that? I would say number 6 adjacent angles. Can be a little tricky. All right, what is the value of M? Now, so you really have to problem solve here. And when you're doing this, this is what I want to see. I want to see you with the paper and pencil. I want to see you working the problems. You can use your workbook. You can use the pages you would have normally used for lesson 6, but use paper to solve this. You're going to have to do just like Duane did in his video. You're going to have to really think in your head. This, we're going to have to subtract a little bit. I'm going to explain why. It's asking what is the value of M. Now, M right here, that's what we don't know. That is the unknown. We've talked about unknowns before when dealing with addition and subtraction. Now right here where it says 70 degrees, it's in red for a purpose because this whole angle, meaning all the way from here to here on these lines, they're 70 degrees. And so you have to subtract. So you take your 70, which is your total, and you're going to subtract what you know. Subtract your known to find your unknown. So you do 70 minus 40. What's 70 minus 40? Easy. Easy money. 30 degrees, okay? And these are all degrees. Okay, so M should equal 30 degrees. It already has the degree sign there for you. So praise them for doing that. All right, so 30 degrees, submit. Let's see if right. Crossing our fingers, because if that's 30, that's 40. This whole thing better be 70. Okay, we did it. That's what you're going to do. Let's do one more. Okay. Now, same thing. Take your pencil, work the problems. If you can do it in your head, good for you. But I still want you to really think through each one of these. What is the value of T? T, we don't know. We know this whole thing is, whole angle right here is 80 degrees. So take our known, which is 80 degrees, or excuse me, our total. We do know it. Then you're going to subtract your known, what you do know. So it's 80 minus 30, it's gonna be 50. So 50 degrees. Let's grab our mouse and let's see if we're right. Cross our fingers. Excelente. All right, now, I wanted to say that was the last one, but I just saw this and I thought, yeah, you're gonna need to know what to do here. What is the value of F? Okay, so if you look carefully, you're gonna notice that now we have 2 here. If we have 2 items next to each other, adjacent, right, we're gonna add them together because what we don't know is the total. Okay, we do know the smaller numbers, the add-ins. So let's take our 30, let's take our 40 degrees as well, and let's add them together. Now 30 plus 40 is 70. Haha, 70 degrees. Okay, so that means that F right here, both those added together, it's going to equal 70 degrees. Let's see if we are correct. Oop, my bad. 70 degrees, and let's submit. Wonderful. Okay, so that's what you're gonna do on here. I hope that helped. Once you have finished your lesson and you have finished IXL, there's still going to be a couple questions for the exit ticket. Now, I am all about making your life a little bit more fun on a Friday. And since it is Friday, I am going to show you the questions that are going to be on your exit ticket. I'm actually going to problem solve with you and tell you what the answers are. And for those that are not watching this lesson video and they end up getting that wrong on the exit ticket, we're gonna know. We're gonna know if you actually watch the math video to find the answers, okay? All right, here we go. So if you're watching these, guess what? You are going to be a champion. Get the answers right. All right, here we go. This question right here. What are the properties of a right angle? Is it A, it measures 90 degrees and it is marked with an arc? An arc looks like this, okay? Is it B, it measures 90 degrees and is marked with a square? A square would more look like this, okay, of course. C, it measures less than 90 degrees and is marked with an arc. Or D, it measures more than 90 degrees and it is marked with a square. Okay, now, this right here, right angle. It can't be less than 90 degrees. It can't be more than 90 degrees. Those would not work. So if it says less than 90, that's an absolute no. If it says more than 90, that's a no. But these both say 90 degrees. So it could be A or B. Let's see. Well, one of them say A, it's an arc. No. When we have 9 degrees, we have to measure it with a square, right? That's how we know. So the answer for that one is B. That is your free answer. And the last question that'll be on your exit ticket is a 33-degree angle is or an Is it A, right angle, B, acute angle, C, obtuse angle, or D, straight angle? Knowing what you know about angles now, here's our 33 degrees. Well, that's more of a like a 40 to 50. Okay, it's going to be a little bit smaller, right? Now, it has to be small. Knowing what we know, it can't be right. That's 90 degrees. Obtuse would be more than 90. Straight would be 180. So the only answer it could be is B. So it looks like we answered B for both. Bada bing, bada boom. All right, friends, thank you so much for joining me. I told you today was going to be a little bit different, and I'm really hoping that you work hard on those IXL lessons. Now, I'm just going to put a plug in here, and just as a reminder, last week it was Friday and we gave you a free day on Friday. This week I'm going to post a social studies lesson, so a link. Now you're going to go to that link and complete just more of an exploratory activity. It's going to be a virtual field trip for your social studies lesson. So I do want you to explore that for social studies today, that a virtual field trip, and then there will be a question as your exit ticket and asking what you did for your social studies, meaning what you did on the virtual field trip. So just wanted to remind you that that will be on there. It shouldn't take you very long, just the regular amount of time you'd be spending on specials any other day of the week. So thank you so much for joining me, and you guys have the best weekend ever, and I will see you next week. Bye.